this video, we're going to cover the organization of the periodic table and how to use the periodic table to find the information that you need. This is the periodic table as we know it today, but it hasn't always looked this way. This is an early version. This is Mendeleev's version based on what we knew at the time. But as we learned more about elements, they started to organize themselves kind of like magic. It was a natural organization, and this is where we are now. It's important to note that not all periodic tables look exactly the same. Sometimes they're color-coded, sometimes they're not, sometimes they're more color-coded than other times, but always you will find that the elements are in the same places because that's how they naturally fall into place. There are levels of organization, and we're going to cover those today. So we're going to take a look first at each block. Each of the blocks on the periodic table represents one element. So here we have hydrogen. Here we have chromium and cobalt, copper, silicon, phosphorus. Some of those sound familiar to you, and some of them may be things you've never heard of, like borium, which is number 107, named for Niels Bohr, or hafnium, rutherfordium, named after Ernest Rutherford. In each block, you're going to find certain pieces of information. One of those things is the atomic number. The atomic number is the number of protons in an atom of that particular element. If it's still an atom, it's also going to have the same number of electrons. So, for instance, hydrogen has 1 proton, and as long as it's still a hydrogen atom, it's going to have 1 electron. Lithium is number 3. That means it has 3 protons. Beryllium is number 4, 4 protons. If you go all the way over here, you'll find number 2 is helium. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's because the periodic table is put in the order of the atomic number. The other information that you'll find is that there's this other number that typically has a decimal, and that's the atomic mass. That's the average mass of an atom of that particular element. It's measured in something called AMUs, or atomic mass units. We also have a symbol. The symbol is either 1 or 2 letters. In this case, we have 2 letters, and the second letter is always going to be lowercase. This is helium, neon, fluorine. Over here, we have sodium, and sodium doesn't look like it matches, and that's because a lot of times the words come from a Latin word, or the symbols come from a Latin word, and it doesn't translate to the English. Same thing with potassium, which is K. You'll also find that the name is frequently on the periodic table, which is really helpful. So Na is sodium, K is potassium, Rb is rubidium. It prevents us from having to memorize the symbols. So that's how each block is organized. But we also have other layers of organization. Here, we have 7 periods. 1, 2, 3, 4, 5, 6, 7. Don't be confused. Here, this is 6 and 7, and they're just taken out and put below the periodic table. Period 1 contains 2 elements, hydrogen and helium, because periods go left to right. Period 2 contains 8 elements, everything from lithium to neon. Period 3 is sodium to argon, also 8 elements, and so on. If you look at the periodic table and you're moving from left to right, you can kind of determine how an element is going to react or how it's going to behave with other elements. So if something is on the left side of the periodic table, on the far left, it's going to react pretty well with some of the things that are over here, minus this column, which we'll talk about later. So the reactivity or the behavior of the elements changes in a pattern as we go from left to right. We also have columns or families. They're called groups or families, or sometimes they're given specific names. There are 18 of them. Group number 1 is everything in this column. Group number 2 is everything in this column. Everything in this column is group number 3, all the way to group number 18. They're also called families, like group number 18 has a specific name. We call that the noble gas family. The reason we call the columns families is because they have things in common. Everything in this column is similar in the way that it reacts to other elements. They don't react, actually. These are our non-reactive elements. Over here, these are extremely reactive. So if you take lithium and you toss it in water, it's going to blow up. If you put sodium, which is a soft white metal, in water, also blows up. Same thing for the whole column. That's one of the things they have in common, just like you have things in common with your family members. So we know each block contains information. We have periods. We have families or groups. We have 7 periods, 18 families or groups. There are some other things that we'll get to later, but I'm going to mention. This whole section on the left side of this zigzag line, minus a couple of elements, these are all metals. And everything on the right side, those are called non-metals. So that's kind of a big deal. Hopefully that helps you to at least figure out how things are organized. But I do want to mention something else. It's hard to understand how scientists took all of these things that we actually couldn't see and figured out how to put them in some sort of order that made sense. But it's taking what you know and finding the patterns. So imagine if you had a deck of cards, and a deck of cards contains 52 cards, but say you only have 50 cards and you're trying to figure out which ones are missing. If you lay them all out in order, you can figure out that it's the 3 of clubs and the ace of spades that are missing. That's the same thing that these scientists did. They knew what was missing. We didn't find all of these elements at the same time. For instance, gallium, which is here below aluminum, gallium was missing for a while, and Mendeleev called it Eka aluminum because it was close to aluminum. And because of where it was going to be on the periodic table, he could tell people exactly what it was going to do. He knew its melting point, he knew that it was a metal, he knew kind of what color it was going to be. So when gallium was actually discovered, he was correct, and it fit perfectly into the spot that he had held for it. Now we have all 118 actually named. 118 was named recently, and it's called oganesson. Its symbol is Og, which seems appropriate for the last element to be named, right? Hopefully that helps you, and as we move forward, we'll get more comfortable with the periodic table.